Addition and subtraction of 2D vectors by analytic method. In general, there are two methods normally utilized in solving the vector addition and subtraction. These methods are geometrical and analytical methods. In this course, we will focus on analytic method because they are faster and more precise. Consider a 2D vector A with direction of theta with respect to positive x-axis. Take vector A to be situated in the first quadrant of xy plane, shown in figure. Geometrically, the vector A can be resolved into its rectangular components, ax and ay. Ax is the component of vector A, along the x-axis, and ay is the component of vector A, along the y-axis. From the diagram, ax is equal to a cos theta, and ay is equal a sin theta. The magnitude of vector A can be calculated by using this equation. Let's do example 1. Resolve vector A and vector B into their rectangular components. Given vector A is equal to 10 meter with the direction 30 degree from positive x-axis. So, the x component can be determined by a cos 30 degree, which equal to 8.66 meter, and y component using formula of a sin theta, and we get 5.00 meter. For vector B, which is 10 meter in magnitude with negative 120 degree, we use the same method to determine the x and y components of vector B. And the answer is like this. Let's take a look another example. If vector A is equal 10 meter with 30 degree from positive x-axis, and vector B is equal 10 meter with negative 120 degree, determine the magnitude and direction of C, if C is equal A plus B, by using the component method. We start to solve this problem by determine the x and y components for vector A and B. Then, add up the x component to find the value for Cx and y component for Cy. After that, calculate the magnitude and direction of vector C by using the formula. So, we have vector C with magnitude 5.18 meter in the direction of negative 45 degree at fourth quadrant. Given four vectors. Vector A is equal to 5 meter with the direction of 15 degree, vector B is 10 meter in magnitude bearing 200 degree. Vector C is 15 meter with the direction west 20 degree north, and vector D, 20 meter at negative 40 degree. Find vector E, if E is the summation of vector A, B, C and D. To make it clearer, sketch the vector in x and y plane. Vector A is 5 meter in magnitude and 15 degree from positive x-axis. So, using analytic method, the component ax and ay are written like this. For vector B, which is 10 meter in magnitude and bearing 200 degree. This will make the angle 20 degree from negative y-axis, and resolve vector B in x and y components. Next, for vector C, 15 meter with direction west, 20 degree to north. Find the x and y component of vector C. Finally, for vector D, which is 20 meter in direction of negative 40 degree. So the component of dx and dy are written like this. Ex and ey can be determined by adding up the x and y components of all vector respectively. With the value ex and ey, we can calculate the magnitude and also the direction of vector E. And we get the answer of vector E is 16.05 meter with direction of negative 80.5 degree.